All right, so seeing how we haven't seen each other for a couple of days, I wanted to make sure that you're on the right track with making sense of those Sig Fig rules. So let's do a little bit of practice together and see where you are with this. So you can, if you want to, you can sort of pretend this is a quiz, see how you do out of the number of questions that we complete, how many you're getting right. So first, so in this question I'm asking you to identify the number of significant digits in each of the following. All right, so take a minute, and I want you to come up with, what your answer is for this. All right, let's take it up. So when I look at this question, I see that it has some zeros here. All non-zeros, of course, always count. But here I have some non-zeros, so and some zeros. So let me think. So these zeros in the middle here are sandwiched, which means that they count. So when I look at this number, all of those digits are going to count. This number has 5 significant figures. All right, next question. So this next question, let's maybe look at, I'd like you to maybe complete the next 2, and then we'll take them up. So pause the video if you need to, and then resume when you're ready. All right, so for the next question, I'm looking at my non-zero, and I have 1 non-zero, but I also have all of these leading zeros. And of course, leading zeros do not count, which means that this digit, this number, has only 1 significant figure. All right, on to the next question. So looking carefully at this, I have some trailing zeros. So trailing zeros count sometimes, but in this case, these are trailing zeros without being after a decimal, which means that they do not count. So this digit, 4,500, has 2 significant figures in it. So hopefully you're doing okay so far. Let's tackle the next couple of questions. I'd like you to pause the video and do these questions, and then when you're ready, resume. Okay, so let's take a look at this first one here. So I have some zeros here. One of the zeros is after the decimal, which means it has to count. And then I have some non-zeros here, and my 0 right here is sandwiched between two values that have to be counted. So in total, this number has, all of those are going to count, so this value has 4 significant figures. Next, so in this case I have zeros in different positions. I have this 1 0 right here which is sandwiched, but I have this other 0 which is trailing. But it's trailing without being behind a decimal. So this 0 does not count, but this 0 here that is sandwiched does. So this value has 3 significant figures in it. And one way to test that is to say, well, can I convert that to scientific notation, and does that 0 need to be there? Well, no, it doesn't, because that would be written as 2.09 times 10 to the power of 3, and then I'd be good to go. All right, so I have one more example here. Let me get rid of this little arrow here for you to go through. Pause the video, do the question, and when you're ready, we can resume and take a look at it together. So when I look at this digit, I see some zeros. So this 0 right here comes after some non-zeros, but those non-zeros are after a decimal place, so I'm going to count that 0. But I also have these zeros right here, which are leading zeros, and leading zeros never count. So in this case, the digit 0.0890 has 3 significant figures. So hopefully you're on the right track with that. I'm ready to do the next section, which is going to ask you to round. Okay, so in each of these questions, I'm going to ask you to round, but specifically I want you to round to 2 significant digits. Let's take a look at the first example here. So 2,349. I'm going to go through this first one together with you, and if you feel like you want to do it on your own, go ahead and do that. So if I'm rounding to 2 significant digits, it means I'm keeping the first 2 digits in the number, and I'm looking to the next digit after that to tell me how to round appropriately. And so in this case, the 4 is less than is less than 5, which means I'm going to round that down to a 0. And so when I round this, I get to 23, but it's 23,049. So I'm going to put zeros there to maintain my place value, to ensure that I've rounded that value and not made it a much smaller number. Okay, let's look at the next example. Okay, pause the video, give this one a try, and then resume when you're ready. Okay, so I need to remember that these leading zeros don't count. So I'm not going to start counting there. I want 2 sig figs beginning with the 7 and the 9, which means I'm looking to the 8 to help me round. The 8 tells me to round up, which means that I'm rounding this to 0.00. Okay, well, let's take a look at this. The 8's rounding up to a 0 because it's a 10, then I need to carry that 1 to the 9. And the 9 becomes a 10 as well. So I'm going to put, and then, so I get a 0 there. And I'm going to carry that extra 1 up here, and that becomes an 8. So I get 0.0080. Now people will say, well, why did I need to add in that extra 0? Remember that I'm looking to add 2 significant digits. So if I leave that trailing 0 off, then I will be left with only the 8, and the 8 would give me alone would give me only 1 significant digits, because of course these zeros are not counting. Okay, let's look at the next example. $699.9. Okay, pause the video and resume when you are ready. All right, so when I look at this, I'm looking at the 6 and the 9, and this 9 right after I'm using to round. And so that 9 will round up to a 10, so I'm going to write that 0 there and carry the 1. 9 plus 1 now gives me a 10, so I'm going to carry that extra 1 up to the 6, and that's going to give me 7. So I end up with 700. But the problem here is that I want 2 significant digits, and 700 only has 1. Which means that I need to write that in scientific notation, because when I write a value in scientific notation, all of the digits count. So I'm going to write this starting off as 7 times 10 to the power of 2, but I'm going to put a 0.0 in intentionally, because by virtue of doing that, I've now indicated that there are 2 significant digits in my value. All right, let's look at some other examples. Okay, one last rounding practice question. Give this a try, and when you're ready, we will carry on. Okay, so looking at this number here, I can see that these leading zeros are not going to count, so I'm looking at the 1 and the 4. And the 5 is going to tell me that I need to round. Remember, it's not 5 flat, it's 5, 1. And I'm going to talk about what would happen if that was a 5, 0 after, or simply a 5. The fact that it's larger than 5 exactly means that I'm going to round up. Okay, so that 5 now is going to round up, so that's going to give me 0.015. Okay, and here I can see 2 sig figs. Let's talk about the case where if I had, let's say, 0.0145 flat. If I had that value, then again I would do the same thing, and I would say, well, I'm looking at the 1 and the 4. The 5 is telling me to round, but I need to round in the direction that makes the digit before an even number. So since it is an even number already, I'm going to drop the 5 and write that as 0.014 simply. Okay, and that's how that rule works. Next on our agenda is to do some calculations here. I'm actually just going to move this up a little bit, so we have a bit more room. Let's hide that for a minute. Okay, so in this question, I want you to calculate each of the following. Okay, perform the calculation, but then round each of the numbers to the proper number of significant digits. Okay, so I want to see how you do. See if you can remember the rule that we apply when we are adding numbers written in scientific notation, or when we're adding numbers and we want to round to the proper number of sig figs. Okay, so let's take a look at this first example here. So the first thing I'm going to do is I'm going to get the raw answer, and the raw answer is just without any kind of rounding involved at all. So my raw value that I get here is 336.52. And so, but I can't leave it like that. When the rule is that when I'm looking at numbers written in scientific notation, when I'm looking at numbers and I want to round to the right number of significant digits, then I'm looking at the number that has the fewest number of decimal places, because my final answer shouldn't have any more decimal places than the least accurate value that I have. So this one has 1 decimal place, and the second measurement has 2 decimal places. So my final answer can't have any more than 1 decimal place. So there it is, and it's a 5. I'm going to look to the 2 to tell me how to round, and that 2 tells me to round down. So I'm going to take that digit and I'm going to truncate it to 1 decimal place. Rounding it, I get 336.5. Hopefully you did okay with that. Let's take a look at the next example. Okay, so go ahead and try that, pausing the video and resuming when you're ready to take up the question. All right, so the first thing I'm going to do is get the raw value here. So I'm going to multiply 5.3 times 101.1. And the raw value that I get, this is before I've done any rounding, is 535.83. And so the rule that we use when we are multiplying digits and we want to know how to round to the right number of significant digits is I look at the total number of digits that count in each of the values that are used in the multiplication. So here 5.3 has 2 sig figs and 101.1 has 4 sig figs. So 2 sig figs and 4 sig figs. So my answer can't have any more sig figs than the value with the fewest, and so that's the 2, which means that I need to go ahead and I need to round my value, my answer, to 2 sig figs. So I'm going to keep the 5 and the 3. This 5 is not simply a 5, it's actually larger than 5, so I'm going to round that up. And so the answer that I get when I round appropriately is 540. Right? So remember, I need to add that 0 in to make sure that I'm keeping my place value. I'm actually rounding and not giving a response that is a much reduced value compared to the original. Okay, next. Here are a couple more examples. I'm just going to move them both up. There we go. Take a minute to work through this next example, and then we'll take it up. Let's see how you're doing with these rules. Okay, so again, I'm multiplying here, and so the rule when I multiply is I need to make sure that my final answer has the same number of sig figs as the value used in the multiplication that has the fewest. So I'm just going to get my raw value here, 0.0300 multiplied by 4,500, and I'm getting 135 for that. Whoa, I don't know what just happened here. Let me rewrite that. 135. So let's take a look at and analyze the number of significant digits in each of the values used to get this 135. So I can see here that I have some leading zeros that don't count, but I do have some trailing zeros that are after a decimal and after a non-zero. So this value right here has 3 sig figs in it. Let's look at the 4,500. So 4,500, I've got these 2 zeros right here that are trailing, but they're not after a decimal. So unfortunately, they don't count. So I have 2 sig figs in that second digit. At least that's all I can assume. And so I have 2 sig figs that should be in my final answer. I'm keeping the 1. I'm keeping the 3. The 5 tells me to round in the direction that's going to make the number before it even. Since it's a 3 and 3 is odd, I need to make sure that my final answer is rounded up to give me 140. All right, hopefully you did okay with that. Let's try one final example, and then we'll be good to go. Oopsies. let's get rid of this. There we go. Okay, try this one last example. Remember that you're going to use the EXP button on your calculator. Some of you may have an EE button, but some of you may also have a 10 to the X button on your calculator. Remember, you don't need to, if you're using EXP or EE or the 10 to the X, you don't need to put in the times 10 part. That's done for you. All right, so I'm going to get the raw value here. And let's just check that you get the same raw value as me. So 3.2 EXP5 times 6.0 EXP3. So my value, my raw value, I should double check that because I'm not sure that I punched that in right. 3.2 EXP5 times 6.0 EXP3. Okay, I'm getting 192, and then there's 1, 2, 3, 4, 5, 6, 7 zeros. So double check that. Your calculator might have put that right away into scientific notation, and if that's the case, what you're getting is 1.92 times 10 to the power of 9. Either one of those is fine for raw values, but now we need to analyze our sig figs. So my first digit has 2 non-zeros, which means that there are 2 sig figs. My second digit has a 1 non-zero, but then a 0 after the decimal. It also has 2 sig figs. That makes it easy. So I'm going to round that to 2 significant digits. The 2 here tells me to round down. And so I'm going to round that value, that final measurement, appropriately becomes 1.9 times 10 to the power of 9. Or if you want to, and you want to keep it in standard form, though I don't recommend this because this is a really large number, I would write this as 1, 9, and then a 0, and then our 7 zeros that follow. There we go. All right, so evaluate where your understanding of these ideas are. If they're really lousy and you're struggling with this, you need some extra support, make sure you come and see me in advance of our quiz, which will be moved to Friday, and I'll be happy to help.